each farmer can produce apples or oranges. And so we will look and think about what we expect to happen when that's the case. And sort of spoiler alert, one farmer will grow apples and the other farmer will grow oranges. So we are going to see specialization. So that's the point of this model, is to explain why we will often see specialization, why we will specialize in playing football and let someone else do our moving. So we're going to think more about opportunity cost in production as it relates to a farm. So this is Andrea's production function. So our first farmer is named Andrea. These are all the things that she can produce. She could produce only apples. She produces only apples. She gets 100. She could produce only oranges. If she produced only oranges, she gets 300. Or she could produce some combination of them. So for example, she could have 50 apples and 150 oranges. All those are options for her. Notice that what I just did was I just condensed the entire operation of a farm into a table. The model does not talk about the cost of switching from apple farming to orange farming. It doesn't talk about what happens if the weather changes. It doesn't talk about whether Andrea should expand her farm. The model is not designed to show Andrea how to run her farm so much as the model is designed to show that there are trade-offs in production. So let's look at Andrea's opportunity costs. So remember, opportunity cost is what you give up in order to get something. So if we move from option 1 to option 2, why she would do this if she wants to get more apples. In order to get more apples, she has to give up oranges. So specifically, if she wants to gain 50 more apples, she has to give up 150 oranges. 300 minus 150 is equal to 150, so she's losing out on 150 oranges in order to get 50 apples. 50 more apples means giving up 150 oranges. Well, knowing the opportunity cost of 50 apples isn't very useful, just like how when you go to the grocery store, you're not really so much interested in the price of 50 gallons of milk. We want to know the price of 1 apple or 1 gallon of milk. So we can look at this like a fraction. One of the things you might remember is we can do any sort of multiplication or division with a fraction as long as we do it to the top and the bottom. So what we're going to do is we're going to divide both the top and the bottom by 50. Well, 150 divided by 50 is 3. 50 divided by 50 is 1. So if we say that giving up 150 oranges gets you 50 apples, that's the same as saying that giving up 3 oranges gives you 1 apple. So for every 3 oranges given up, Andrea gains 1 apple. Which means that for Andrea, the opportunity cost of an apple is 3 oranges. What do you have to give up in order to get an apple? She has to give up 3 oranges. Another term we want to learn is something called constant opportunity costs. So constant opportunity cost just means that at any point on her production possibility schedule, she has the same opportunity cost. And so whether we're going from option 1 to option 2, or from option 2 to option 3, it is always the case that she gives up 150 oranges. Notice she's giving up 150 here, giving up 150 here, and gains 3 apples, or gains 50 apples. Gain 50, gain 50. So give up 3 to gain 1. The opportunity cost of an apple is always 3 oranges. So this is not often realistic. But it simplifies the math a lot for what we need. So if you imagine someone who has a lot of, some big company that has lots of farmland all over the world, there's going to be places where apples grow really well, and there's going to be places where oranges grow really well. And so the opportunity costs of growing an orange are going to vary a lot of, okay, am I just starting off and I have apple orchards everywhere, and I'm going to put a few orange groves in Florida? Well, those orange groves are going to be really productive because oranges grow well there. On the other hand, if I'm growing lots of oranges and the only thing left for me to do is try to put some orange trees in Michigan, well, that's not good. That's going to be a high opportunity cost because Michigan is not weather appropriate for growing oranges. However, for what we want to do, we're okay with assuming constant opportunity costs. Essentially, the reason we're okay with that is if I adjusted the model so that opportunity costs change, we would still get the same result. It would just make the math a lot more confusing. So what we've done so far is everything over here, right? We talked about the opportunity cost of an apple. Now what we're going to do is talk about the opportunity cost of an orange. And essentially, everything is just inverted, right? This math is just this math inverted. Notice we go from 3 over 1 to 1 over 3. Give up 3 oranges to get an apple becomes give up 1 apple to get 3 oranges. The opportunity cost of 1 orange is a third of an apple. Again, nice thing is we get inverses here, right? The opportunity cost of an apple is 3 oranges. The opportunity cost of an orange is a third of an apple. Next, we'll look at Bridget's production schedule. So Bridget is our other farmer, and we're going to say she also has three possible ways of producing. So she could produce only oranges. That's option 1, and get 200 oranges. Option 2 says she could produce 100 apples and 100 oranges. Option 3 says she could produce just apples, in which case she can grow 200. So this brings us to a question. Let's see how you can do solving this one. What is Bridget's opportunity cost of producing an orange? So do what I just did for Andrea and try to do it for Bridget. Okay, so what's her opportunity cost of producing an orange? Answer here is A. Her opportunity cost is 1 apple. How do we know that? Well, in order for her to move to from option 1 to option 2, she gives up 100 oranges, gains 100 apples, or we could look at it as going from option 1 all the way to option 3, giving up 200 oranges, gaining 200 apples. In any case, it's give up 1 to gain 1. So this next slide is going to summarize what we found so far. So what we've done so far today is calculated the opportunity cost of apples and oranges for Andrea and Bridget. So the opportunity cost of an apple, for Andrea, the opportunity cost is 3 oranges. For Bridget, the opportunity cost is 1 orange. How about the opportunity cost of an orange? For Andrea, the cost is a third of an apple. For Bridget, the cost is 1 apple. Next, we will look at this really powerful term called comparative advantage. So what we've done so far is we've presented 2 different production possibility schedules. What we haven't done yet is figure out how they relate to one another. What is it? We have Andrea on one side and Bridget on the other. At some point, we're going to try to think about why are they each going to specialize in one? So comparative advantage thinks about the question, what if LeBron is better at both basketball and baking, right? So this is the idea that what if the football player is better at both football and moving? Well, comparative advantage is the ability to produce a good at a lower opportunity cost than another producer. So now let's look and see the opportunity cost comparison for Andrea and Bridget. So the opportunity cost of an apple for Bridget is 1 orange, for Andrea is 3 oranges. What opportunity cost of an orange for Bridget is 1 apple, for Andrea is a third of an apple. So comparative advantage says, can you do it at a lower opportunity cost? So here, producing an apple, Bridget has a lower opportunity cost, so she has a comparative advantage there. For producing an orange, Andrea has a lower opportunity cost, 1/3 is less than 1. So Andrea has a comparative advantage at producing oranges. Next, let's look at something pretty neat. Let's suppose that Bridget comes up with some sort of innovation. So here I have an example of going from the original John Deere plow to modern farming equipment. And we're going to say that however she does it, Bridget is able to become 10 times as productive. So it used to be that if she only produced oranges, she could produce 200. Now she can produce 2,000. Things she used to be able to do 100 of each. Now she can do 1,000 of each. Used to be she could do 200 apples. Now she can do 2,000. So she's much, much more productive. Far more productive than Andrea is. However, let's think about this. After the innovation, what is the opportunity cost for Bridget of producing an apple? The answer here is B. It's an orange. It's one orange, which is what it was before. It's still it's the same. Notice that what we just these list of opportunity costs we showed a couple of slides ago, all of that is still true. And because all of that is still true, comparative advantages are still the true. Bridget still has the comparative advantage at making an apple. Andrea still has a comparative advantage at making oranges. And this is true even though Bridget is better at producing everything than Andrea is, right? Bridget, with her new technology, could make lots of apples and lots of oranges. However, when we boil things down to the opportunity cost, what we're going to see is that comparative advantage still holds, and that each of them has comparative advantage at one thing. So Andrea has to give up only a third of an apple to get an orange. So even though Bridget's better at everything, Andrea still has a comparative advantage in producing oranges. Because when Bridget grows an apple, the world loses out on one orange, right? There's one fewer orange in the world. When Andrea grows an apple, the world loses out on 3 oranges. So there's 3 fewer oranges in the world. Whenever there are 2 individuals and 2 goods, unless they have exactly the same production schedules, each person will have a comparative advantage in one good. So even though Bridget's way more productive at everything, Andrea will always have comparative advantage in one thing. So even if the football player is better at both moving and playing football, the mover has a comparative advantage at being a mover, not because the mover is so great at moving things, but because they're so bad at football. So let me illustrate what I mean by how the world loses out how the world is losing out on more when Andrea grows an apple, right? So if Andrea grows an apple, the world is 3 oranges worse for it. So on the left, I show the option where nobody specializes. So each of them want to eat apples and oranges, so each of them are going to grow apples and oranges. Our total world output of apples and oranges is here. 150 apples, 250 oranges. What if instead I convince them both to specialize? So they specialize. Andrea only grows oranges because that's where she has a comparative advantage. Bridget only grows apples because that's where she has a comparative advantage. Now our total production is 200 apples and 300 oranges, which you'll note means that there are more apples and more oranges produced, right? We compare these two, we get more apples and more oranges. And this is really cool because it didn't require us to come up with some new technology. All we had to do was let everyone do what they do best. However, we still have this issue where, this is nice to say, and it's great that the world has more apples and more oranges. Andrea still doesn't have any apples, and Bridget still doesn't have any oranges. So let's think about what that implies. Well, Andrea is only making oranges, and Bridget is only making apples. They both want to eat more fruits. Andrea has to give up 3 oranges to make an apple. Again, that's if she says, you know what, I have this mountain of oranges, and it's great that the world is better off and has more oranges. I just want to eat an apple. So in order for Andrea to do that, she has to give up 3 oranges. She stops growing 3 oranges, and in exchange can grow an apple. Bridget, mountain of apples, says, you know what, I don't want to just eat apples. I want to grow an orange instead. She gives up 1 apple to make 1 orange. Okay. What if instead we get them together? We say, you know what? I have an idea. Rather than one of you having to switch to grow 1 apple, one of you switching to grow an orange, what if instead of growing both goods, they decide to specialize and trade? So I'm like, hey, you know what? Why don't you try trading? Let's see if we can figure out some way to make a trade that makes everyone better. And we'll say they agree on a price of 2 oranges per apple. So now let's think about this. It used to be if Andrea wanted to get an apple, she had to grow it. And for her to grow an apple, she had to give up growing 3 oranges. Now, we're going to think about, maybe will they make a trade of 2 oranges per apple? Well, if she does that, now she only has to give up 2 oranges to get an apple. She's going to like that, right? If I want an apple, when I was growing it, I had to give up 3 oranges. Now, trading, I only have to give up 2. Bridget's side of things, it used to be if she wanted 1 orange, she had to give up 1 apple. Now, however, because of trading, now she knows that, if I give up an apple now, Andrea will give me 2 oranges for it. So, big takeaway here is that Andrea and Bridget are both better off. And let's review why this is. When in farming, so this is if there's no trade, the only way to get something is to grow it yourself. Well, Andrea has to give up 3 oranges to grow an apple. Bridget has to give up 1 apple to get 1 orange. Now, Andrea only has to give up 2 oranges to make an apple. When she trades 2 oranges for an apple, Bridget, when she gives up 1 apple, will get 2 oranges. Both better off. And notice, again, they're both made better off without them having to come up with some sort of new innovation. All they have to do is meet each other and agree to trade. So some really cool things to notice here. First, the benefits are due to different opportunity costs. So even if Bridget's productivity at both goods increases by 1,000%, both parties still benefit from trading. So notice that there's another thing to notice. There's not like a winner and a loser here. Both of them are made better off. There's nothing magic about the price of 2 apples. Any price between 1 and 3 oranges per apple will make both people better off. And all this logic extends to trade between countries. So Andrea could be making cars in Japan or clothes in Bangladesh or chocolates in Belgium. The important thing to note is that there are gains for both Andrea and Bridget if they meet and exchange and each does what they do best.